Welcome to lesson 4.1, sampling and surveys, day 1. So let's talk about a little scenario. An airline has just finished training 25 junior pilots, 15 male and 10 female, to become captains. Unfortunately, only 8 captain positions are available right now. Airline managers announced that they will use a lottery process to determine which pilots will fill the available positions. The names of all 25 pilots will be written on identical slips of paper, placed in a hat, mixed thoroughly, and drawn out one at a time until all 8 captains have been identified. A day later, managers announced the results of the lottery. Of the 8 captains chosen, 5 are female and only 3 are male. Some of the male pilots who were not selected suspect that the lottery was not carried out fairly. Do these results provide convincing evidence of discrimination? So in order to feel that there was truly convincing evidence of discrimination, we need to feel that beyond a doubt that we are quite sure that discrimination happened. Provide 2 explanations of what could have transpired then. We think this could have gone one of 2 ways. 1, the lottery was carried out fairly, resulting in an unlikely outcome. Or 2, the lottery was rigged, resulting in the selection of 5 female captains and 3 males. So that's kind of where we're at right there. We think that maybe it was fair, but maybe it was rigged, okay? And maybe they were trying to meet some quota of having enough female pilots, okay? So a little bit about the class. Make sure that you have some tabs in a binder, that you've logged into the practice of statistics textbook, and that you have logged into the AP Classroom. Okay, here's an activity that we'll do in class. Let's proceed, though, to the next page. Okay, this little write-up here explains a little bit about trying to identify an unknown author of a book, and it turned out to be J.K. Rowling. Okay, what is the difference between a population and a sample, and what is a census? The population is, in a statistical study, is the entire group of individuals we want information about. A sample is a subset of individuals in the population from which we actually collect data. We hope this subset represents the entire population. So if I wanted to know how seniors felt about off-campus lunch, I could, instead of trying to ask every single senior, I could try to take a sample of 100 seniors and get their input. And then I could try to globalize and think that that's the way that the rest of the senior class and the senior class as a whole, how they feel about off-campus lunch. Okay, a census collects data from every individual in the population. In order to perform a census, we have to ask every individual. So this would be this would be questioning every single senior. So that includes ones taking a week in Aspen. This includes ones taking a long weekend on a college visit. This includes ones that are seniors that are expelled or placed in another school, seniors that are having difficulties and are in a hospital somewhere. So you have, the census is tricky because you have to reach every individual. Okay. For example, identify the population and the sample in each of the following settings. The student government at a high school surveys 100 students to get their opinions about a change to the Bell schedule. So we want to identify the population and the sample. The population is this school's whole student body. The sample is 100 students that were picked. It's important to make a distinction between the population and sample, that the population is everybody that could have been picked, but the sample is just those that were picked. Also, the population, we have to be specific about who they actually were. We weren't trying to sample from other high schools. We were just trying to sample from this high school. The student government at a high school surveys 100 students. So we have to make sure we don't say that the population is all high school students in the US. This question is only curious about how these high school students feel at this particular school about the Bell schedule. Okay. All right. The quality control manager at a bottling company selects 10 cans from the production line every hour to see whether the volume of the soda is within acceptable limits. The population? Let's think. It's not absolutely all soda cans. We have to be specific and say it's a soda cans produced on this production line. The sample is the 10 cans selected for inspection. Okay. We want to make sure that we can narrow it down to those that were actually being looked at and inspected. Okay, how to sample badly first. Choosing individuals from a population who are easy to reach results in a convenient sample. What is the problem with this kind of sampling? It often produces unrepresentative data. In fact, we can normally find that all these people or things or animals that were easy to reach all kind of have something in common. So if I think of trying to sample birds in the wild, and so I'm going to look at nighthawks. Nighthawks commute, I'm sorry, they don't commute. They travel really far distances on heat waves way up high in the air. And maybe those that are weaker will come down and rest more. If I was to try to sample them, I'm going to have a hard time getting the ones that are way, way, way high in the air for my sample. So I would probably collect those that dip down more and are a little bit weaker. Now, if I use them in my sample, then I won't be getting a representative group of the whole of nighthawks. I would be sampling just those weaker ones. So if I'm looking at them for size or for something about appetite or strength, they don't actually represent all nighthawks. Okay, for example, go to Mr. Sherman's room at 6:30 and ask the first 15 students who arrive about how much time they spent doing homework last night. Why would that run into issues if you were trying to generalize about how much homework time all of RB spends on average per night? Well, maybe it's an easy thing to do because maybe you didn't plan your survey right. And it just requires you to wake up early and it's a day that the survey's due and you're thinking, I'm just going to Sherman's room and I'm finding people, then it'll give me enough time to whoop out the project and turn in this project of surveying students about homework. Okay, not a good plan though. If you went at 6:30 to Mr. Sherman's room and asked 15 people about how much time they spent doing homework in the last week, then you're going to get a really high average number of minutes spent doing homework. Why? Because those people that are in Mr. Sherman's room that early are really hard workers. They probably have really high homework loads because of their courses that they're in. For them to even know Mr. Sherman, they probably had to have already been in honors classes. So it's going to be an overestimate of the number of minutes the average student spends on homework at RB. Using a method that will consistently overestimate or consistently underestimate the value we want to know is called bias. Now, the key here is that if something really is going to produce bias, the way that we talk about it in AP Stats class, we need these things. We need either a consistent overestimate or a consistent underestimate. That means that if I went back to Sherman's on Tuesday and did this, if I went back to Sherman's on Wednesday and did this survey, if I went back to Sherman's on Thursday morning and did this survey, that I would keep over and over and over again getting an overestimate of the mean number of hours that a student at RB spends doing their homework over the last week. Okay. All right. So that's really key. Bias is not just getting extreme results. Okay. It's getting results that are extreme in one direction that if you repeated the survey over and over, it would consistently overestimate or consistently underestimate. Okay. All right. AP exam tip. If you're asked to describe how the design of a study leads to bias, you're expected to do two things. One, identify a problem with the design, and two, explain how this problem would lead to overestimate or underestimate. Okay, the memory game. We would do that in class, so I'll keep moving forward. A voluntary response sample consists of people who choose themselves to be included in the sample by responding to a general invitation. This is like if you throw out a poll on your, I don't even know now, is it Twitter that has polls or Facebook that has polls, and you're just asking people if they feel about how they feel about an issue, then people who respond are considered a part of your sample, and they're called voluntary response, where they are a sample that consists of people who choose themselves to be included. Okay. People who just pass by your poll aren't in your sample, but those who respond to your poll are therefore in your sample, and they are self-selecting if they're going to be in. You didn't use a method to randomly find people and to make sure that you're representing people of all walks of life, or people of all ages, or people of mixed gender, balanced somewhat neutrally. Okay. So, for example, online polls is an example of a voluntary response. An Instagram poll is an example of a voluntary response. People pass by it, or they choose to be a part of it, and they're choosing to be a part of the sample. Dancing with the Stars, people are calling in. And once they call in, they're a part of the sample of answers. And if they don't call in, then they're not a part of the sample. But the sample selection process is determined by the guests, the people that actually join or don't join your survey. American Idol, same thing. They're calling in and they're selecting to be a part of your survey. Is this a good method for obtaining a sample? No. Hence why it's a part of bad sampling methods. They're usually not representative of some larger population of interest. Okay, they're usually people that feel strongly. These types of voluntary responses attract people who feel strongly about an issue and often share some opinion with each other, which is bias. Okay, so in other words, if we were to wonder who you were going to vote for in an upcoming election, you'd get the people who feel strongly to reply, and those people who don't really know or don't really care aren't going to reply. And so it might result in bias. Okay, so then check your understanding. For each of the following situations, identify the sampling method used. Then explain how the sampling method could lead to bias. A farmer brings a juice company several crates of oranges each week. The company inspector looks at 10 oranges from the top of each crate before deciding whether to buy all the oranges. This is called a convenience sample. This could lead the inspector to an overestimate of the quality of oranges if the farmer puts the best oranges on top. Okay, the ABC program Nightline once asked whether the United Nations should continue to have its headquarters in the United States. Viewers were invited to call one telephone number to respond yes and another one for no. There was a charge for calling either number. More than 186,000 callers responded, and 67% said no. So they said no, they should not continue to have their headquarters in the United States. This is a voluntary response because people are self-selecting to be in the sample. This could lead to bias because only those who wish for the United Nations to stay in the United States won't try as hard and won't call in because they are already getting what they want. But those who are against hosting the large UN meetings, feeling it's a safety risk, etc., will want the headquarters moved and will call in with more likelihood. Okay. All right. What is the purpose of the check your understanding up above? Is just to make sure that you guys are kind of on your toes and thinking for yourselves, and that you're making sure that you're learning. Okay. So to continue, sampling and surveys, how to sample well. The drum roll, please. Okay, random sampling involves a chance process to determine which members of a population are included in the sample. Okay, that's really important that we have some sort of random chance device that's choosing the members to be in our sample. So if we wish to sample if eating hot dogs every day for a year is bad for your health, we can't just have people who only choose themselves to be a part of that study. We have to make sure that we randomly sample those due to a chance mnemonic or some other chance device, so that we get people of all race, people of diversity of age, people of a diversity of healthiness, so that we get unhealthy people and healthy people, and maybe rich and poor, and people with good hygiene and those with bad, and just all the risks to make sure we get all the risk factors and all the healthy people all included. A simple random sample, abbreviated SRS, of size n is chosen in such a way that every individual and every group of n individuals has equal chance to be selected in the sample. So girls are as likely as boys to be selected. People from Guam are as likely as people from the US, let's say. Whatever your population is, then every group is just as likely to be selected. So that also means that the first 10 people in an alphabetical list are just as likely to be selected as the last 10 people and any of the people in between. If you were trying to choose people of size 10, and let's see. Yeah, I think that's it. You can get 10 girls, you can get 10 boys, you can get also a mixture. Okay, so all groups are equally likely. Okay, including if the whole group has a characteristic. Okay, example, pulling names out of a hat, rolling a die, flipping a coin, using technology, or a random digit table. These are all some of the most common ways to select a SRS, a simple random sample of people. Okay, and that results in these two outcomes. Pulling names out of a hat is the easiest to describe if you had to write about it. So if you were trying to write about a situation and tried to recommend doing an SRS, it's not always practical though, because let's say that your population is like every 16-year-old girl in the US. Could you really put all 16-year-olds' names on a slip of paper, fold it, put it in a hat? It's kind of odd. Okay, roll a die. There's only 6 outcomes though. So let's say that you really have a room of 6 people and you want to roll for each of them to decide if they are in your sample or not, then that might work. Okay. So let's see, flip a coin. There's only 2 outcomes though, so you can only have 2 treatment groups, let's say, and you can flip a coin for each person and see if they're going to be in treatment group A or B. Technology is great because it can handle a large list of people. And here's how to get to random integer generator. So then you can generate maybe, let's say, like 500 random integers for a list of 1,000 people. And whichever 500 numbers were chosen, then you go to the designation list and figure out what each person was numbered in the numbered list, and then you can choose those 500 people. Or random digit table. In table D in the back of the book, it's provided. This is not easy to describe. We will practice it very shortly. Okay, what is the difference between sampling with replacement and sampling without replacement? How should you account for this difference when using a table of random digits or another random number generator? All right, so sampling with replacement, each individual has a chance of being selected every time. So this is best simulated by coin flips or die rolls. Without random or without replacement, individuals already chosen no longer have a chance to be selected. So every trial, there are fewer individuals left and the probability of selection increases. When sampling people, we always are sampling without replacement, because if I want to choose 10 people and I put Becky and Bob and Brett in my group, it wouldn't make sense for me to leave Becky back on the list and for me to select Becky again to be my 4th person in my group, in my sample. I would keep crossing people off the list and I would sample without replacement. Okay. Okay, common error. When using a random number generator, you must explicitly state that repeated integers should be ignored. You want to generate numbers until you get n different numbers in a specific range. Okay, so say Pitchford wants to select 3 of us to answer a warm-up. With a random selection process, we wish to select 3 individuals from our class of 20. Using technology, we will generate numbers 1 through 20, and assigning numbers 1 through 20 to our classmates, we will select 3 unique classmates using math probability random, ignoring repeats. So right here, I'm emphasizing with these words that we are ignoring repeats, okay? 3 unique classmates are selected, meaning Jenny, Jim, and Jason, okay? and we're going to ignore repeats. So if Jenny's number came up twice in this list that we generate, we're going to ignore it and we're going to go to the fourth number. Okay, we generated numbers 2, 10, and 11 corresponding to Pierce, Stephen, and Sierra. Okay, the key components: number your individuals, ignore repeats, and identify our sample in the end. Mall hours. The management company of a local mall plans to survey a random sample of 3 stores to determine the hours they would like to stay open during the holiday season. Use Table D at line 101 to select an SRS of 3 stores. Okay, so that means that we're going to use line 101 to select an SRS of 3 stores. 101 is right here. The first store is 19. 19's right here, Star Jewelers. Oh my goodness, here's a line of digits. Well, anyway, 19. Next is 22, and that's how we read the table of random digits. We read it, in this case, 2 digits at a time, because each of these stores, there's 21 total stores, so the only way to choose store 20, 21, or 19, or 15, or any of these here is to have 2 digits. Now then, when you start counting the line of the table of random digits, you want to count by 2s. In that case, then, we want to number these 01 to 21, because if we're counting by 2s, we would never select a 1-digit number. So if I count by 2s, I can only select 10 to 21, and I wouldn't be able to select those. But if I number these 09, 08, 07, then I'm essentially looking at all 2-digit numbers from 00 to 99, but I'm only interested in actually selecting from 01 to 21. So my first one is 19, that is a store. Next is 22, that's just too high. And I keep going even though it's a little tedious. 39, 50, 34, 05. 05 is my next store, Carter's Kids, and I keep counting 2 at a time. After 05, I count 75, nope, 62, nope, 87, nope, 13. 13 is my last store in order for me to select 3 stores. So now let's talk numbers. There's a lot of numbers here. I have 21 stores, but I'm more concerned about the number of digits in 21. That's 2 digits. I want to count my table of through my table with as few digits as possible. So I'm not going to label this 021, okay, and count by 3 digits at a time, because I don't have over 100 options here. I only have 21 options here. 21 is a 2-digit number, so I'm going to use 2 digits. Also, you must number all of your individuals the same number of digits, hence why I need 2 digits here in 01 through 09. Also, make sure that you count by a specific number of digits and that you look at that many digits at a time and that you skip then on to the next one. So you don't count this as 19, 92, 22, 23. You count it as 19, 22, 39, and you count right across this gap. So why is there a gap then? There's a gap really just to organize the digits instead of just smushing all of them right in a row. They thought this looked a little bit more visually appealing, and it made it a little bit easier to find a pattern as you go so you don't skip any digits by accident. Okay. All right. We labeled the store with as few digits as possible, but the same number of digits. Those are 2 key components of using the table of random digits. We labeled them 01 to 21. We read through the table of random digits, line 101, left to right, 2 digits at a time, skipping numbers outside 01 to 21 and skipping repeats until we selected 3 unique stores. I'm emphasizing that uniqueness and skipping of repeats. Okay, we chose Carter's for Kids, Mrs. Fields, and Star Jewelers. Always finish with listing which you selected for your sample. All right. What does it take to earn full credit on examples like the one at mall hours? Be explicit. Make sure that you are writing like you're doing an exercise in futility. You are describing every detail of how to use a table of random digits. Okay, so the number the individuals with as few digits as possible in the same length of digits. The interval you are using for selection, 01 to 21, has to be specified. Okay, skip repeats. Okay, ignoring values outside that interval, and select until you have n unique individuals. Okay, then list your selection. Okay. All right. Now, what I'd like to do is just a little exercise. Say you're going to select 10 people from a list of 100 people. What would you do? First, we should start with discussing how we're going to number the people. Take your list of 100 people and number them what? How about 0, 0 to 99? That is actually 100 digits. Okay. And then also, we're going to read the random table of digits left to right, counting all people, selecting until we select 10 unique people from 00 to 99, skipping repeats. Obviously, if we count 2 digits at a time, there's no other 2-digit numbers from 00 to 99, so I don't need to specify numbers outside that range until we have 10 unique people selected. Now, if you were to read the random table of digits starting at 101, you'd read 19, 23, 39, 50, 34, 05, 75, 62, and so on. But you're probably going to run into some repeats along the way. So make sure that you're specifying that you're skipping those repeats. Okay? All right. Let's move on. Seed your calculator, enter your student ID, store math probability 1 rand. Okay, suppose we want to estimate the yield of our cornfield. The field is square and divided into 16 equally sized plots, 4 rows by 4 columns. A river runs along the eastern edge of the field. We want to take a sample of 4 plots. Using a random number generator, pick a simple random sample of 4 plots. Place an X next to the plots you choose. You're using these commands then. Math, probability, randint, low, high, and then the number you want to select. So you go math, probability, randint. You're going to choose plots 1 through 16, and then you want to choose 4 of them. Okay, now my 4 that my calculator chose were 2, 4, 5, and 15. Okay, then I'm going to use the backside in order to figure out how much corn was in each plot. So let me move on to the next type of sampling though, just so I can run through all my sampling methods. Now randomly choose 1 plot from each horizontal row. This is called a stratified random sample. So I'm going to go randint, low, high, and that's it. Okay, randint from 1 to 4. And my calculator chose 3, 4, 3, 4 when I did that over and over and over again. Okay, so I'm choosing 1 from each row, but I'm letting a calculator choose. Finally, randomly choose 1 plot from each vertical column. I'm going to do the same thing, randint, low, high, and do it here and select the one that my calculator selected, here, here, and here. Now, what do we know about corn? If this is my irrigation, the fact that it's near a river, then I'm going to think that 4, 8, 12, and 16 are going to have the biggest yields, and that 1, 5, 9, and 13 are going to be a little bit drier and aren't going to have as big of yields. But when I numbered them 1 to 16, my calculator could have ironically chosen all the ones by the river, all the ones away, or all those in between. And so I have a lot of a diversity of answers. I could have had a really high yield answer, but Justin could have had a really low yield answer, and Jenny could have had a really medium yield answer. And so we're going to have a lot of diversity of answers. Over here, because we had to choose from this row, this row, this row, and this row, we are I'm forced to choose one from here, which could have been low yield or high yield, and then from here, which could have been the same, lower, high, lower, high, lower, high. So all of mine were probably pretty high yield corn, but other people could have all gotten really low yield corn. So it seems like by stratifying by row, that we're not singling out that characteristic that makes us guaranteed to get high yield and low yield and medium yield included in our sample. So these estimates are still going to have a great variety of answers. But these estimates here, when I stratify by vertical column, I am making sure that I get one of the plots with low yield, one of them with a little bit higher, one of them with a little bit higher, and one of them with the highest yield. So when I stratify by the characteristic, the wetness of the field according to the closeness to the river, when I stratify according to this characteristic that most affects my outcome, my yields of corn, then I can get answers that are all closer to other answers in the sample. Why would that be important? If you only are choosing one sample and you are relying on that sample to make a generalization about the population, then you want your sampling method to be a method that gets you close to the true population estimate, or the true population value. Okay? So in this case, and in this case, your answers can be far from the true population mean number of corns per square, okay, per plot. But using this method, your answer should be closer to the true mean amount of corn yield per plot. So use this side, use these to figure out, this is the actual yields per plot. Okay, and we see the numbers go up as we get closer to the river. Use this to figure out how much yield there was. Now, when I did this last year, I got these answers using my SRS. It was pretty low and pretty high, from about 40 to about 110 bushels per acre or per plot. This was about the same, 40 to 125, pretty extreme. Okay. Remember that this is a small sample of students that were able to participate. We would expect a mound shape, okay, and less data on the tails and more in the middle. And then look at how much the data values moved inward. Okay, no tail information from about 70 to about 80. Wow. Okay, so when we stratify by the characteristic that most affects the outcome, then we are getting a lot less variety of answers. Therefore, if you had just one answer, you could rely on it a lot more to be like the true population value. Okay, so let's talk about that. What is a stratified random sample? It's a sample obtained by classifying the population into groups of similar individuals called strata, then choosing a separate SRS in each stratum and combining these SRSs to form a sample. Choose strata based on facts known that make each strata similar within in a way that influences the poll outcome. Okay, so we chose strata based on the fact that they were dry or wet or somewhere in between. Okay, and that would most affect the poll outcome because water helps corn grow. All right. For example, research the effects of cat food. Should not make strata based on the cat being only cat, with other cats, or with other dogs. These are interesting facts about cats if they are an only child cat, or if they have sibling cats, or if they have dog siblings. Okay, you should instead choose age. Okay, it seems obvious, right? Choose little kittens, choose ones that are still pretty much kittens, ones that are middle age, and ones that are old. Or choose weight. Okay, is your cat fat and out of shape, or is it super thin and runs around and is a healthy cat? Okay, and then try to measure the effects of the on the cat that the food has. Stratified random sampling works best when the individuals within each stratum are similar with respect to what is being measured and when there are large differences between the strata. Okay. So pick the variable with the strongest association to what you are trying to measure. When is a stratified random sample beneficial to use? What is the benefit? The benefit is that when is it beneficial to use is when there are clear distinct groups within the population. Its benefit is that it creates a more precise estimate. Estimates will be less variable from one to the next estimate, okay? From one to another. How is stratified random sampling different from simple random sampling? Stratified random sampling and simple random sampling have the same abbreviations, SRS and SRS, but realize that when we say SRS that we're only referring to simple random sampling because that's just such a great sampling method that we abbreviate it, and the other one we don't. However, stratified random sampling really kind of comes up strong because it creates so much less variety, okay, in the sampling process. Now, why isn't that one then chosen to get the abbreviation? And why aren't we saying that stratified random sampling is the king version of sampling? Well, in stratified random sampling, we don't get the fact that every group is equally likely to be represented and that every individual is equally likely to be represented. Because look at the corn again. If we were to just count for equal representation, we would look at the fact that there's only 4 current corns here, but 150 corns here. Wouldn't it be more likely to choose some of the corn in some of these places where there's a lot more corn? Now, I know that we only chose plots, so any of the 16 plots were equally likely to be chosen, but that's kind of that idea of more popular and more populated and less populated is kind of what makes SRS have that component that each individual is equally likely to be chosen and each group is equally likely to be chosen. Saying that getting the first 10 people or the last 10 people or any other 10 people in your 10-person sample is equally likely. Whereas in stratified random sampling, maybe you would partition each of the groups and then you would say that you want to guarantee representation from each group. But then it's not likely that the first 10 people would be sampled like an SRS can do. So they figure that SRS includes the most randomness. So that's why that one gets the abbreviation and gets such respect. Okay, so, but stratified random sampling is kind of the bomb diggity for getting really awesome, less variety in your samples from sample to sample. So depending on the strata size, not every individual in the population has an equal chance of being selected in the sample. So let's say that you're going to, oh here, I have the detail here. Example, stratify by country. Okay, so let's say that I want a sample of people from around the world, and I'm actually going to try to guarantee that every nation has some people chosen or a person chosen, depending on how small the countries are and how big my sample is. So not all countries are the same size. The likelihood to be selected in Lithuania is greater than the likelihood to be selected in Russia. So an SRS, a simple random sample, gives everybody the same likelihood of being selected. You would put everybody in the world's name on a list, number the list, choose a device to select those people, and then those people would be in your list. And there might be none from Lithuania and from some of the smaller countries, where Russia, Brazil, USA, India, China would all be much higher likelihood of being represented in the list just because there's so many more people from those countries. Okay, I have a sore throat, so I hope that's it. Oh my goodness, there's more. Okay, so cluster sample. To get a cluster sample, start by classifying the population into groups of individuals that are located near each other, called clusters. Then choose an SRS of the clusters. All individuals in the chosen cluster are included in the sample. Okay, so SRSs include performing an SRS, Stratified random sample includes performing an SRS. You break the groups into strata, and then inside each strata, you choose an SRS from each strata. So does cluster. Cluster, though, means that you classify people into groups of individuals that are located near each other, just to make it kind of a little bit more convenient, but it also makes it more feasible when you have massive amounts of people. And then you choose an SRS of all your clusters, and all the individuals chosen in the cluster are chosen in the sample. So you perform an SRS, you number your clusters, let's say 1 to 20, and let's say that you choose cluster 4, then all the individuals in cluster 4 are in your sample. Why do we use a cluster sample? For practicality's sake, save time and money. It works best when the clusters look like the population, but on a smaller scale. So how is a cluster sample different from a stratified random sample? In stratified, strata are similar within, but different from strata to strata. For example, young, middle-aged, and old. Take some from all the strata. But in cluster, you would probably take families. So you'd have a group called the Young family, a group called the Midlothian family, and a group called the Acapella family, and you would number them 1, 2, 3. Use a random number generator. 2 is selected. So all from the Midlothian family are in your sample. Okay, for example, stadium seats at an NFL game. Clusters are different within, but similar from cluster to cluster. So how could you do stadium seating? Well, they should be, if you look at it like the 100 level, the 200 level, and the 300 level at a stadium, you might just choose all of section A to be in your cluster. So your clusters are going to be your letters around the stadium, and then you would choose a chance device to select a letter. So your clusters are your letters from A through L, but if you were going a stratified route, you would choose 100s, 200s, 300s. You would make sure that you have people from the 100s, people from the 200s, and people from the 300s. But hey, clusters does that. Isn't that cool? Okay. A good read. A school librarian wants to know the average number of pages in all the books in the library. The library has 20,000 books arranged by type, fiction, biography, history, and so on shelves that hold about 50 books each. Explain how to select a simple random sample of 500 books, and explain how to select a stratified random sample of 500 books. Okay. For the 500 books using the simple random sample, label the books 1 to 20,000. Use a calculator, math probability randint, 1 to 20,000, 500, until you select 500 unique books, repeats ignored. 500 books is your sample. Explain how to select a stratified random sample. For strata, use the genre. Number the books within each genre. Start with the first genre, 1 through N. Choose an SRS. Repeat until SRSs of each genre until you have 500 books in your sample. Explain how to use a cluster. For clusters, use the shelves. We said that they're arranged by type on shelves that hold about 50 books each. Number the shelves 1 to 400. Select 10 shelves. Every book on the 10 selected shelves is in the sample. Wouldn't that be easier to do? Okay. Discuss a potential drawback within each of the methods described above. SRS is a lot of work to number all of your books, running around to locate the books. For strata, what is a disadvantage? A disadvantage is probably the same. It's going to take a lot of work to number all the books within each strata, and then to go to each type of book and to, for each genre and to find those. And for cluster, there might be genres that are totally unrepresented, and maybe by chance some of your genres might be similar to each other. So let's say that biographies tend to be shorter than science fiction novels. Then if you have a lot of other short genres, then you might have a lot of short books selected. And Yeah, you might not get a good representation of the number of pages in each book. The process of drawing conclusions about a population on the basis of sample data is called inference because we infer information about the population from what we know about the sample. The margin of error is the most we expect a sample proportion or sample mean to be off from the true proportion or the true mean. We did not think we made mistake in our sample selection, and this does not have to do with inherent bias we believe could be present. Its margin of error is just related to sampling variability, the amount that samples naturally vary from one to the next one. That just is kind of recorded back here when we did our plots. This is natural sampling variability. We didn't control the fact that some people's calculators chose a lot of high yield plants, and other people's calculators chose a lot of low yield plants, and that other people's calculators did a guess towards the middle. Okay. What is the benefit of increasing the sample size? Increases precision, it decreases variability, and it does not affect accuracy. So it does not mean that your sampling method is better or that you are losing bias. It just means that you are getting a more precise estimate. Your estimate should be closer to the true estimate, or at least should be closer to other repeated estimates. That's what precision means. What is a sampling frame? I never see this word on an AP test, but it's included in our teaching, so I'll include it here. It's the list of individuals from which the sample is drawn. Okay, so if I listed individuals from 1 to 1,000, and then I chose a sample, that original list before the sample was selected, that original list is my sampling frame. Okay, so it's important to sometimes make a distinction about the sampling frame and the people who weren't on the sampling frame, like people in jail. Where did they really make it to your list? Did you consider choosing them? Or students who are expelled, or students who are having a mental illness crisis and are outplaced in a hospital for a couple months? Okay. Undercoverage occurs when some members of the population cannot be chosen in the sample. This means that during the sample selection process, that the list of the population from which you are using the sampling frame to create your sample, the sample frame has people missing. Like I was just discussing, doesn't include your hospitalized students, your expelled students who are outplaced to a behavior school. Does it include students with special needs? Does it include people with special needs? Does it include people in nursing homes, people in jail? Okay. Example, use the first day's attendance list, number the students, and use technology to generate an SRS of 100 students. What is wrong with this? It leaves out students who were absent the first day or transferred to RB the second day or third day. This can lead to bias. Remember, undercoverage occurs before the sample is created. Non-response occurs when an individual chosen for the sample cannot be contacted or refuses to participate. It sounds the same as undercoverage. Undercoverage, however, refers to the fact that they didn't make it onto the list, so it's kind of the surveyor's fault, okay? The surveyor didn't consider these other people, okay? Non-response, though, is when you actually conceived your sample frame, made your sample, and it includes Fred, Franny, and Joseph. And you go to Fred, Franny, and Joseph, and each of them spit in your face and say, no, I'm not talking about that with you. Okay, that part is non-response. So non-response is spit in face. Undercoverage is in jail. What problems might this cause? Non-response leads to bias, even if the sample selection process was carried out properly. So let's say that your question was, have you ever had an abortion? Okay. Not everybody's going to feel comfortable answering that. And likely the people who feel the most uncomfortable are those who have had an abortion. So, sorry to bring up the A word. We're not supposed to talk about that. So let me change it up. Let's talk about, like, do you go to church? I think that maybe people aren't going to answer that because they don't feel comfortable, because they don't really feel comfortable with their religion choices, or they feel guilt, or they dislike what their family practices. So maybe that'll lead to lying, okay, and or lead to them not participating in your, that's what I really mean, lead to them not participating in your survey. So then it leads to bias because it consistently leads to an underestimate on the church question or an overestimate of the proportion of people who go to church. I could see that argue either way. Anyway, how is non-response different from voluntary response? Oh boy, so many things so similar. Okay, non-response is when the person was selected for the sample, but the person is refusing to participate. So the person is actually self-choosing to be out of the sample. Voluntary response is 100% the people are choosing to be in the sample. So the survey was optional. Anybody who has opted to take part will respond. Therefore, non-response isn't possible. Okay, that's a really important distinction for voluntary response. Those people who didn't volunteer are not non-response. Those people who didn't volunteer are just not a part of your sample. Okay, non-response is that the person was selected for the sample but is refusing to participate. Voluntary response, we don't actually select anybody. They select to be in themselves. All right, last vocab. Response bias is a systemic pattern of inaccurate answers to a survey. How is this caused? Wording of the question is the number one way response bias occurs. So if I say, are you seriously thinking of voting for Acorn? Okay, then I am really making it sound like Acorn is an acorn, okay? Is an idiot, has a wooden head, okay? And it makes it harder to answer yes, I am voting for Acorn, okay? Other forms of response bias are just people lie. People exaggerate their answers. So maybe people are exaggerating and saying that they go to church every week when really it's like 10 times a year. The appearance of the questioner. Are you like an upstanding person and you're asking somebody if they drink? Okay. And they don't understand. Okay. So say that I'm curious where somebody stands on women's suffrage. Well, women's suffrage is the right to vote. Okay. And so somebody should say, I'm for it. But women's suffrage sounds like you're talking about women suffering. So you're probably going to accidentally get a lot of people to say they think it's awful. Okay. But really what they're saying is that they think women voting is awful, but they shouldn't be saying that. Hopefully, don't feel that way. Anyway, but hey, that's kind of appearance of the questioner. You know that I'm a woman. Okay, okay, anyway. Maybe also people don't remember the info accurately. So maybe they're exaggerating their answers and saying they go to church every weekend because kind of in their head they do, but except for the weekends when they have anything else going on. Okay, so there you go. That is all of 4.1. I hope you enjoyed, hope you learned a lot, and I hope that you got all that down. Good luck.